Hi, this SOS video is about finding ways to determine if a situation or set of data should best be modeled by either a linear or an exponential function. So just remember, a linear function is when new terms are created by repeatedly adding a constant value. An exponential function, new terms are created by repeatedly multiplying by a common factor. So if I want to determine if a function is exponential or linear, I'm going to take one term, just remember, not the first term, and subtract the previous term. If I do this a few times and get the same constant value, the function is linear because I have found the common difference. If that doesn't work, you can take one term and divide by the previous term. If you do that a few times and get the same result, then you have found the common ratio, the factor, and the function is exponential. So in the following practice problems, you're going to decide whether each function below is linear or exponential, and you're going to write the equation that models the function. Okay, so let's see with the first table. This looks like it's going up pretty consistently, so I might think maybe this is linear. I'm going to take one number, 345.6, and I will subtract the previous one, minus 288, and I get 57.6. I'll do that again with a different set of numbers. So I have 288 minus the previous term, 240, and I get 48. So that is not the same result. So that's not a common difference. This is not linear. Let me try exponential. I'm going to take 345.6 and I'll divide by the previous term, 288, and I get 1.2. Let's try that again with a different pair of terms. I have 288 divided by the previous term, 240, and I get 1.2. So I know this is exponential because to get to each term, I'm going to multiply by 1.2. That's my common ratio. Okay, so let's think about how with just the information here, I could write an exponential function. So I start off with h of x equals, well, if this is my first term, 240. I'm going to multiply by my common ratio, 1.2. And since this is a first term, this would be to the x minus 1 power. Well, maybe I want just a straightforward exponential function. But if that's the case, I need to find my starting term, my initial term, my 0th term. Well, if I multiply by 1.2 to get to each term, to get to the next term in the sequence, then to go backwards, I would divide by 1.2. Remember, 288, well, let's see how that works out. 288 divided by 1.2 does give me 240. So let's try that again. We're going to take 240 divided by 1.2, and I get 200. So my 0th term is 200. So I could also write h of x equals my initial amount, 200, times my common ratio to the x power. And remember, anytime you write an equation, let's make sure it matches the table of values that I can create on my calculator. So I go to y equals. I'm going to type in my first formula, 240 times 1.2 to the x minus 1. And I go to my table of values, second graph. And sure enough, the first term is 240, second one is 288, and so on. Well, how about my other formula? So I'm going to clear this. I'm going to type 200 times 1.2 to the x power. And I'm going to press second and my graph key. And I still get the same numbers. So I know both my formulas work. Okay, let's take a look at this next table. This does seem to be going up consistently. So what we're going to do is see if this would be a linear function. I get out of this second mode to quit. I'm going to take any number, so say 716.47, and I'll subtract the previous one, 775.18, and I get negative 58.71. Well, let's take another pair of terms and see if that works. 833.89 minus the previous term, 892.6, and I get that same result. So I have just found that I am going to add negative 58.71 to each term to create the next term. This is my common difference. Okay, so what kind of equations could I make with this? Well, with the information I have here, f of x equals, I could say, well, here's my first term, 892.6, and we have minus 71. Wow, 58.71 times x minus 1. Let's see if that works in y equals. 892.6 minus 58.71 times x minus 1. Let's see if our table of values matches. My first term is 892.6, 833.89, and so on. So it does match. Another way I could write this is in slope-intercept form. So remember, slope-intercept form, my common difference is my slope. So it's negative 58.71x. And my y-intercept is my initial term, which I do not have. But if I was going to add negative 58.71 each time to get to the next term, the opposite would be to subtract negative, which is the same as adding a positive 58.71. Let's see how that worked. I clear out of this. 833.39. What happens if I do the opposite and I add 58.71? And I get my previous, I didn't get that, so let me see up. I look back here and I made a mistake entering this. 833.89 plus 58.71. And I do get my previous term. So let's do that again. We're going to take this term, we're going to add a positive 58.71 and get my initial value. So 892.6 plus 58.71. And I get 951.31. So that would be my y-intercept. Pretty large y-intercept, but that would work for the sequence. So you know what we're going to do? Let's check it in our calculator. We go to y equals, we clear that. We type in our new formula, negative 58.71 plus 951.31, and we go to our table of values. Oh, made another mistake. Don't know why with that, so let's try this again. Y equals, instead of a negative, I put a minus sign. So let's make that a negative. Go to your table of values. Wow, this is not my day. I forgot to put in my x. Negative 58.71x plus 951.31. All right, third time's a charm. Let's see what happens. Second graph, and my first term, 892.6. My next one, 833.89, and so on. So I know this also is an equation that works, that would model the situation. Okay, the last part of this video is asking you, is it linear or exponential? So I'm giving you different situations. You want to tell me, is it linear or exponential? And you can tell me what keywords helped you understand which choice to make. So pause the video, fill this in, and start the video again and see how you did. Okay, how'd you do? So if this is a monthly deposit of a fixed amount, this is linear because it's a constant amount. Every month you are depositing $326. The next one would be exponential because when I see the word factor, I know I'm going to use that to multiply. And when we multiply by 1/3, that's going to give us an exponential function. This next one, when I talk about a rate and it's a percentage, that's going to be exponential. And finally, 75 cents per mile. That means every mile you're paying 75 cents. That's a constant amount, so that would be a linear function. And that's the way to determine if a situation should be modeled using a linear function or an exponential function. This has been another SOS video.